Hello guys, hope you're doing well. Welcome to this new lesson on formula and variations. It's actually a continuation of what we did last time, and today we are just working on more examples on how to change any of the letters in a certain formula to be the subject of the formula. And kindly, before I begin, please subscribe. Just a few seconds to let you subscribe. Okay, thanks. So we start with example number 1. So we start with example number 1, whereby we have s is equals to 2 pi r squared plus 2 pi r h. We want to make h the subject of our formula. And as I mentioned previously, if you want to make either of the letters the subject of the formula, what you normally look out for, number 1, is that letter that you are being asked to make it the subject of the formula, but you have to locate it where it is the first thing. So then after locating it, check whether it has a square root, it has any power. But if it's just wherever it is, it just has power 1, then the next step is to bring all those terms that have that letter to the left hand side, then the other terms to the other side. In our case, in this formula, where we have h is only in this second term, only the 2 pi r h, and fortunately the h has only power 1. It's just a 1, so that one will be easy, because if it's just power 1 wherever it is, then the next step is to bring all those terms whereby we can see the letter that is of interest to us to the left hand side, but it's only appearing in just one term. So we bring the 2 pi r h to this side, 2 pi r h to that side, to the left hand side, then the other terms now to the right hand side. So here we are going to have s minus 2 pi r squared. Since we want h, and it's just appearing in just one term, then the next thing is to ask ourselves, what are we going to do so that we remain with only h alone? Because we only want h to appear on the left hand side, then everything else goes to the right hand side. So the only way that we can do that is by dividing both sides by 2 pi r by 2 pi r. 2 pi r cancels with 2 pi r, and your h is equals to s minus 2 pi r squared divided by 2 pi r. And example number 1 is done. Example number 2, and please kindly, before I proceed to example number 2, kindly, the 2 pi r on the numerator part and the 2 pi r in the denominator, they can't cancel each other, simply because the first term and the second term of the numerator, they are being connected by a negative sign. If it was a multiplication sign, then that one would be fine. If it would have been either multiplication, if it's division, then we could have cancelled to simplify further. But since it's minus, then we have to leave it like that. So example number 2, we have p is equals to k1, k2, all this divided by t squared, and we are required to make t the subject of our formula. So where is t? Yes, we can see t. It's only appearing in just one term, and that term is in the denominator of this fraction, the k1, k2 divided by t squared. So we've seen it, the first step. Step number 2, does that t where it is, does it have a power 1 or a power which is more than 1? It's a power which is more than 1, and in our case it's power 2, it's t squared. So we have to, as we continue working out on this, we have to bear in mind that for us to get a t, just t, we have to find square root at some point, because we have t squared. And for you to get t, then it means you have to find the square root. So before we get there, the t is part of a fraction. The t squared is part of a fraction. So we have to multiply both sides by t squared to get rid of the fraction. We have to, let me write it afresh. We have to, so this one is supposed to be p is equals to k1, k2 divided by t squared. So we have to multiply both sides by t squared on the left hand side and the right hand side, so that the t squared and the t squared cancels, and therefore we don't have any fraction right now. So we have t squared p is equals to k1, k2. Alright, so the t squared is on our left hand side, and that is okay. So the other thing now is to ask ourselves, what are we going to do so that we remain with only the t squared? The only way we can work out this is divide both sides by p. And dividing both sides by p, the p cancels with the other p, and we remain with t squared is equals to k1, k2 divided by p. But we don't want t squared, we want t, and therefore we have to find the square root both sides. Hence we remain with t is equals to the square root of k1, k2 divided by p. And that's your answer for example number. Example number 3, we have k is equals to 2 pi and then the square root of t all over s, and we are supposed to make s the subject of the formula. So let's first identify where is s. And as you can see, s is in part of this term where they have, it's a fraction, is t over s, and then again there is a square root. So for us to remove the s out of the square root, the only way that we can work out this is to square everything so that the square root goes away. So we have to square everywhere. K squared is equals to 2 pi. Be keen here. You have to square those two. This is t all over s. Let me change it like that. This is the same, t over s power 1 over 2, as I mentioned previously on my previous videos on logarithms. I said whenever you have m root n, this is the same as m power root 1 over n. So this is the same as when you have the square root of t over s is the same as t over s and then power half. And since we are squaring both sides, so we multiply by a 2 there, so that these 2 and these 2 cancels out. So we have k squared is equals to 4 pi squared, right? You can see where it's coming from. Yes, okay. Then t all over s. Now we want s, and we still have a fraction somewhere, so we have to multiply both sides by s, right? S cancels with that, and we have s k squared is equals to 4 pi squared t. We want only s, and therefore we have to divide both sides by k squared. We have to divide both sides by k squared. Sorry, k squared goes with the k squared, and therefore our s is equals to 4 pi squared t divided by k squared. And we are done with example number 3. Example number 4, a1 divided by a2 is equals to b2 divided by the square root of b1. Make b1 the subject of the formula. So here we are just going to work it out the way we've done for example number 3, because we want b1, but in this case the b1 is under a square root. So the first thing before you even do anything else is to square everywhere. Square everything, and then the square root disappears. So we have A1, we have to square it. We have A2, we have to square it, is equals to B2, we have to square it, and then we have B1, 1 over 2, and then we square it. Hope you are together. Okay, so this is the same as A1 squared all over A2 squared is equals to B2 squared divided by the 2 cancels the 2, and then we remain with B1. Okay, so now from there the next step is to cross multiply A1 squared multiplied by B1, and it's because we want to get away with the fractions. So let's cross multiply, and after doing the cross multiplication, we are going to have A1 squared B1 is equals to A2 squared B2 squared. Okay, all right, and we want B1, so what we can do is just divide both sides by A1 squared. A1 squared cancels with A1 squared, and therefore B1 is equals to A2 squared B2 squared divided by A1 squared, and you are done. It's just as simple as that. I hope you've understood how I'm working out those examples. And yeah, that's the end of today's lesson. Kindly subscribe, like, comment, and share. And see you in the next video. Thank you. Bye.